6.2 for day 2. Very short, important little lesson. With linear equations, we have a couple of special cases. And they're so strange looking that they can boggle us when we see it. With linear equations, we're used to seeing two variables because we graph them on a plane that has x and y, and we're used to two variables. So what happens when we see a linear equation? Let me pause this for a second and hide something. That has just one variable, okay? X equals 3. You're told to graph x equals 3, and you're told this is a linear equation. And we're used to making a table and plugging in values and then getting out ordered pairs. And this is really strange. So if we tried to make a table for this equation, we could. And we would say, let me make a little vertical table here. This is such an easy equation, I'm not putting it into the table. We've been using like -2, -1, 0, 1, and 2, right? And so when we plug in -2 into this equation, this is really strange looking, but look at what it says. -2, when we plug it in, equals what? And we plug in -1, and what do we get out? -1 is plugged in, and it equals supposedly 3. It doesn't make any sense, does it?
No.
Mathematically. And we plug in 0, and when we plug in, so this doesn't make sense, because -2 doesn't equal 3, does it? -1 doesn't equal 3. So actually, we can't say that. So let's go to the graph. Where does x equal 3? Yes. Where does x equal 3? Somebody tell me, Gavin, where do I go from 0, 0 to get to x equals 3? When you're pointing, can you say the direction you just pointed? To the, do you know what that is?
Right.
That's the right. So we're going 1, 2, 3. So does x equal 3 there? Gavin, what is this point? Tell me, give me the order pair. X is 3 and y was 0 there. Okay? That's true. X is 3 there. Okay, can anybody tell me another place where x is 3? Stuart. From here? From here?
Yeah.
So you want me to go 3 up from the point we just put? 1, 2, 3. Right here. So give me the coordinates of that point. 3, 3. Does everyone agree that x is 3 there?
No.
X is 3 there. Look at it. Name the point. It's at 3, 3. X is 3. That's true. Where's another place where x is 3? Brian? So 3 and, it's interesting that you're choosing all these 3s. So 3 and -3. So is x still 3 there? Yes. So now we actually have 3 points. Are they forming a line?
Yeah.
So we could draw a line through them. And there you go. This is a special case. The name of this line is x equals 3. It's such a tiny little equation that you would think it would be easy, but these tend to be very hard. When you have an equation that says x is 3, what type of line do we call this? Is this a horizontal or a vertical?
Horizontal.
Everyone?
Vertical.
It's a vertical. The way that you can, Audrey, the way you can remember horizontal is when you go to the beach and look at the horizon, what direction is that? It's left to right, horizon, like out at the edge of the ocean. Let's make a definition for this. We have vertical lines, and vertical lines are what you get when you have x equaling any number. So as a rule, we could write it as x equals a. Those are vertical lines. It's kind of ironic because the x-axis itself is horizontal, right? And yet, when you have an equation that says x equals 3, you have a vertical line. It's opposite the x-axis. Okay, Gavin? Okay, so let's try it with the y. Y equals -1. And if we start at 0, 0, Gabe, where do we go to find a y value of -1? When we go to -1y, do we go left, right, up, or down? You have to choose only one answer. Is it when you go to y is -1? No, that would be x is -1. See that?
Right.
And that would be x is 1. We're trying to get to y is -1. So how do you fly -1? Down, that's right, we go down 1. Okay, so the first point we can place is right here. That is at x is 0, y is -1, right? And where else is y -1? Somebody give me a second point. Kate.
Across
Left 1, and then if I go left 1 and stay at 0, I am not at y equaling -1. Okay, so that would be x equaling -1. So I've got to do something else. Izzy? Let's say I go over here to 4, but 4 is at a y value of 0 right here, right? So now where would I go? Down 1. There it is. That's at 4, -1. Do we still see a y value of -1? Yes. So we're just looking for points that have a y value of -1. We could do the same on the left. -4 and -1 is right there. -4, -1. So now we have 3 points, which you can see are forming a horizontal line. So when you have an equation that says y equals some number, you do get a horizontal line. The y-axis is vertical, but you get a horizontal line. Isn't that opposite what you would think, right? Which is what makes this tricky. Okay, here's the rule. Y equaling any number gives you a horizontal line at that number. So if I wanted to make an a line at a horizontal line at +3, a horizontal line way up here. Can anybody write that equation for us? Would all of the x's be the same, or would all of the y's be the same? All the y's. And what are all the y's there? So the equation is y equals 3. See, it really is kind of easy when you pause and think about it. Okay? But it's tricky. So look in your book at page 322. You're going to graph 2 graphs on one coordinate plane and 2 graphs on the other. This first coordinate plane, you're going to graph y equals -4 and x equals 3/2. On number 8 and 9, you're going to graph y equals 5.7. And the other graph is x equals -1. Oh gosh, sounds similar to what we just did, doesn't it? So you're going to graph 2 graphs on each plane, and then you're going to check your work up here. So go ahead and try. So confused. So with the first one, y equals -4. If you start right at the point of origin 0, 0, where do I go to y equaling -4? Do I go up, down, left, or right?
Down.
Down. So you go 1, 2, 3, 4. And there's one point that is at y equals -4. Okay? And now who can give me a second point where y equals -4? Audrey.
0. Oh wait, that's only just a -4 and -4.
-4 and -4 right over here. Excellent. And really, that's all you need, right? 2 points define a line. If you have 2 good points, you now have the line. There it is, y equals -4. Okay, so you simply have to always start at the point of origin, right in the center, and then go to where that value is. So Colin, x equals 3/2. How else could we say 3/2? 2 goes into 3 how many times?
1.
So, and then there's a half left, so we could say 1.5, right? 1.5. Another way of saying 3/2. So if I start here at 0, 0, which way do I go to get to where x is 1.5?
Down.
If I go down, isn't that y? Y is,
Oh, we're going X, so then we go to the left.
and isn't that negative?
Yeah,
The left is negative. No, this is a positive 3/2. Positive.
Okay, then you go to the right.
Good. So we go to 1.5. So there's a point where x is 1.5. Now where else is x 1.5? Is it going to be to the left, to the right, up, or down? Up and down, right? So here is 1.5 when y is 2. And here is 1.5x when y is -1. Did I say 2? I could have said 1. Anyway, there you go. So all of these points, straight up and down, it should be very vertical, are at where x is 1.5. Okay? Isn't it amazing how such a simple equation can be such a hard thing to grasp, you know? But once you spend this time and effort working on it, then it will pay off and you'll get them every time. Okay, let's start with y equals 5.7. So if we start again at the point of origin, right in the center, everybody's going to tell me which way to travel, up, down, left, or right to get to y equals 5.7. Which way?
Up.
Down.
Up.
I'm filling in where I don't see those dashes. This then would be 5. 5.7 would be close to 6, right? Getting up there. So here is the point at y value of 5.7. And now which way will the line go? Or where is another value of 5.7 for y? Olivia Shane. Where else do we have a y value of 5.7? Would it be left, right, or down, up? Left, right, that's right. So we're going to make our horizontal line. And there we go, we did it. Okay, and the last one, and how about 8 and up here? We have an x at -1, so where am I going to go?
Down.
Is this x is -1 down here?
Oh, wait, no, left.
To the left, good job. So here we go, x is -1 here. Got to get to that starting spot. Okay, and then where else will x's be -1? Colin? Down, I heard down, where else? Up. So it is a vertical line, up and down, and it should be right through that point with arrows on either end. Okay? So today's assignment will involve equations with just one variable like that you have to graph, and also some that involve two, so that they're mixed together. Okay? There you go.